Hello everybody. In this episode we're going to talk about trees, another data structure, and we are going to actually use the Golang and we're going to implement the binary search tree. And let's get it started. I have to make myself load, and yeah. So this is actually related with the previous episode. Remember, we were talking about linked list, and we're going to define similar struct. We're going to define a node. And this node is going to be struct, and it is going to have similarities, let's say data, and it's going to be integer. And this time, it's going to have the node left and right. So why did we define this left and right? Let's go and figure it out. So let's imagine here we are starting with the number 8. And this time, it's not going to be linear like the linked list. It's going to be in the tree shape. So let's say the next number is, if it's bigger than 8, it's going to go to right side. If it's smaller than 8, then it's going to go to left side. Let's say the next number is 2. Let's say 4. So it's going to go to left side. And let's say the next number is 5. So it's still smaller than 8. And it's going to go after 4. But this time is the right side. Let's say number 7. And let's say another number which is 2. This time it's going to be left, and from here it's going to go to left as well. As you can see, it's shaping to in the tree. Let's say the next number is bigger than 8, let's say 12, then it's going to go to the right side. Let's say number 6. Number 6 is smaller than 8, bigger than 4, then it's going to go here, and it's smaller than 7, so it's going to go here, number 6. And you got the point. So that is going to be the structure we're going to follow. So let's continue. We are going to have the binary search tree struct, and we're going to build everything around that. And what do we need is a root node, and this is going to be node as well. And this is going to be struct. And at the very beginning, we're going to have two functions. It's going to be func binary search tree, and yeah, it's going to be insert. We're going to give the value, and it's going to insert another function, which is going to be also BST. This time it's going to be recursive version of this, so it's gonna return node. That's one thing. And what is going to have the parameter is going to have actually the node and the value. So actually, as a bonus thing, we're going to cover recursion as well. It's super important, and we're gonna try to figure it out as much as we can in this lesson. So let's start with defining our BST, and it's going to be BST. Let's insert 8, and next is smaller 5, and it goes like that. Let's start with small, 2 of them. So what do we need at the first? We need to of course the top one, which is root of the tree. So let's go with this one. So we're gonna do BST insert, and we're gonna give the BST root and the value. So that is the initial point. So we're gonna give and don't forget it's gonna be nil. So because we don't have anything yet. So we need to cover that condition. If the BST root is nil, then we have to have the root, and we have to define the first node, and it's going to have the nil for the left and right. right? So we at the beginning we don't have anything here, and we're gonna just return, yeah, return the BST root. That's it. Second one, when we come here, the root node is full, right? So we are sending the root. So we skip this, and then when we come here, we have the node. Let's say if node data, it is bigger than or equal to value. So which is the case for now, right? We have the 5, which is smaller. So what are we gonna do? We have the node, but the left and right side of the node is empty, right? So we have to assign the left side of the node. What we're gonna assign is we have to call this again, BST insert. This is the recursion part. And we have to assign the value, but at the same time, we have to pass to BS node left as well. So so this node is the root node, right? And the left side is empty. So we have to pass that, which is nil, and it is gonna assign the value in the second level. So we're talking about the second level now. So we have the root condition, but we need another one. So if the node is nil, then what we're gonna do? We're gonna return node, empty node actually, with the value, but the left and right is empty. So when we did this, it goes return from the second level to the first level, and we have to return the node. Yeah, so we are returning from second level to the first level, which is here, and we define the left one as a node, this node. So what do we have now? As a final, we have the root node, which is 8, and the left side of it, it's not nil, and the right side is nil. Let's start with the right, and here we have another node, which is 5 and nil, right? That's the current situation. Let's go from the here to right side. Let's go 6. So we go start 8, go left, and we're gonna go right. Let's skip this for now. So we're gonna iterate on this. So we're starting. We have at the very beginning. Let's talk about this one. At the very beginning, we already have this, right? So we have it already have this. So imagine instead of that, this is coming. With the when we call insert track, it goes with the root, but root has already these values. And the root, this condition goes, and this condition goes because we already have the root. And this time, we have the data of what? 6, right? And the value is 6, and the node data is 8. So what it means, it goes to the left, right? And we go to the second round with the with this node. So the node is not empty, so we're gonna skip this 2, and we're gonna come here, and we're gonna check if the 5 is smaller. Sorry, the 6 is smaller than the 5. No, it's not. So we need another condition here. If the value is bigger than the node data, then we do the same for the we do the same for here. And this time we do the insert, and we go to actually the third layer. In the third layer, if the node is empty, yes, it is empty because we are sending this one, right? It is the right side. And then we return the node with the value of 6 and nil. So it's actually, it goes back to the second level, and it assigns here the new node. which is 6 nil nil. All right, so now it goes to the, from third go to second, and from second it goes to the first, and we go out with the returning to not to the root. And yeah, if we look quickly, maybe debugging this and see if everything is assigned correctly. And we have the root and the left and the right is going to be assigned right after this. And yeah, maybe quickly one another with the big one, let's say 30, and this has to go to the top and the right side of the top, and yeah, it has to fill this one, right? So this will come here, 30 nil nil. And let's try it out. Stop and rerun. Let's see. Left is 5 and the right is 30, correct, and the left also has the one right, and that is working. All right, let's keep it this one as it is, and maybe we go a little bit further in the next one and look for searching feature, how we can introduce for this small script. Yeah, we're going to take it from there, but for now, thank you for watching. I hope it was helpful. Please subscribe to the channel and like the video, and yeah, if you have any comments or questions, you can write it down to the comment section. I will see you in the next one. Bye.